Okay, remember this 2062 mold down here that we made? It's this spoked shaped part. Well, we've got these pins right here, and these core pins are down in here, and then we've got these ejector sleeves that strike the part off of here. And we also have the leader pin right here. This is a leader pin, and then we have this bushing right in here. And I wanted to talk about the tolerance stack ups on this type of a setup. So I'm just going to go ahead and turn on the section view, and I'm going to look at this thing from a, let's see here, from a straight on view. And what we have is down here, we've got the core pins on this backing plate, and then this plate strikes forward with this ejector sleeve. And you'll see that there's a gap between here and here. So there's a little bit of room so this can work through there. This thing is stationary, so it doesn't need any tolerancing. But as we go up, we see the same thing on the ejector sleeve. We see a gap around here that doesn't make the striking of this sleeve have to work and grind against this material. We want to minimize the surface that it grinds against. And so as you come up here, you'll see that this sleeve has the same thing on the inside of it. And so the only working surface is up in here, and we actually put a gap between here, a small gap that's the difference between this surface and this one right here is like, oh, 0.01 millimeters. And so we have this thing, it's referred to as the land right there. And then we do it up here too. So there's always little gaps. We always want something a little bit bigger and something a little bit smaller. And the pins arrive this way, so they'll slip nicely, and we actually can send vapors down through here that are trapped in the cavity. But we always, when we go to make this hole, we want to make the hole on this part bigger than this part right here. So we do that with a thing called a reamer. So we drill out the backside. We bring the drill point up close to here, and we leave this land right here. It's probably, I don't know, like 3 to 5 millimeters of a tighter slip fit. So this is a slip fit, and the reamer that makes this, I believe, is a 10 millimeter hole. So we'll go 10.01, and on the slip fit hole when we ream it. So we'll drill it undersized. We'll drill it like 9.75, and then we'll ream it right after that with a 10.01 reamer, and then that gives us this nice slip fit. So things don't bind up, because if they start binding up, people start putting grease in here to make it work, and it just doesn't work. So you have to engineer that into your mold design. Okay, so that's slip fits and tolerancing on pins, and the same thing goes true down here on these type of connectors, are the leader pin and the dowel here. So these are all real tight precision, and we have to press fit this bushing in here. Let me see if I can hide this right here. Whoops. So that pin slips in here, and this is a metal graphite bushing. They drill holes around here, and they stick graphite in here all the way around it, so it's self-lubricating. But we have to press fit this in. This is a line-to-line fit when you put this bushing in. And then that leader pin that comes in there, it's already ground undersized. So you buy these in a pair. You buy the pin and that together. Okay, so that's where we're going. These also are return pins for the return plate on the ejector plates, and this has an oversized drill and ream on this working pin. So this is our guy around the backside that we, if we look at these right back here. So this has that same clearance drill, and then a looser slip fit for this pin to work. So this is our return spring that pushes this plate assembly back. All right, that's what we got, and I'm sticking to it.